In this lesson, we'll be using the converse of the Pythagorean theorem to first determine whether a triangle is a right triangle or not, and then we can also use the converse to classify a triangle, whether it's acute, right, or obtuse. So the converse just means we're changing the order. We're starting with if c squared is equal to a squared plus b squared, then I know that triangle ABC is a right triangle. And again, C is always the hypotenuse, always the one that's by itself. The longest side opposite the right angle. Okay, so when we don't know if it's a right triangle, C is going to be the longest side. All right, so example 1, we're going to tell whether the given triangle is a right triangle. So what you're going to ask yourself is, does C squared equal a squared plus b squared? So I know that the square root of 13 is going to be somewhere between 3 and 4, probably about 3.5. So 3 times 3.5 is going to be more than 9. So this is my longest side, so that will be C. And then for A and B, 6 and 9 are interchangeable. It doesn't really matter. So I'm going to see if I square 3 root 13, does that equal 6 squared plus 9 squared? And so if I square everything in my parentheses there, 3 squared is 9, and the square root of 13 squared, they just undo each other, they're opposite operations. So I have 9 times 13, does that equal 6 squared, which is 36, plus 81? And so when I multiply out 9 times 13, I get 117. And if I add these two together, I also get 117. So that means that this first one is a right triangle, because c squared equals a squared plus b squared. For our second example, my longest side is 23, so that will be C. And so again, does c squared, or 23 squared, equal a squared plus b squared? 23 squared is 529. 20 squared would be 400. And 11 squared is 121. And so when you add those together, you can see that they do not add up to 529. They actually only add up to 521. So it's almost a right triangle, but not quite. So not a right triangle. All right, so down below here, I have 2 for you to try on your own. Go ahead and pause the video and see if you can find the answers on your own. Okay, so for number A, or letter A, when you set it up, you should have had 24 be your C, and when you figure it out, 24 squared does not equal 21 squared plus 16 squared, therefore it is not a right triangle. For the second triangle here, I noticed that all of these can be divided by 2.5, so I'm going to divide by 2.5. If I do that, this one's going to equal 5. If I divide that by 2.5, it equals 4. And if I divide that, 7.5 by 2.5, it equals 3. So I have a 3, 4, 5 triangle. It's a Pythagorean triple. I don't even have to test out a squared plus b squared equals c squared. I already know that that is a Pythagorean triple, therefore it is a right triangle. not only can we use the Pythagorean theorem to determine if it's a right triangle, we can also use it to classify triangles. So first of all, if c squared is less than a squared plus b squared, then triangle ABC is acute. Oops, that is not a good color. And if you think about it, an acute angle is going to be less than 90 degrees. So as long as you always set it up with c squared on the left, it's going to make sense. Acute angles are smaller and obtuse angles are larger. So if c squared is greater than a squared plus b squared, then I know triangle ABC is obtuse. And again, whenever you have an obtuse angle, it is greater than 90 degrees. So when you do these problems, always start with your c squared. You're using the converse, so change the order of the equation too. For example 2, we want to know, can segments with lengths of 5, 7, and 9 form a triangle? And if so, is it acute, right, or obtuse? So the first thing we have to do is use the triangle inequality theorem. We have to make sure that the two shorter sides add up to more than the longer side. So if I look at the two shorter sides, I've got 5 and 7. I want to know, how does that compare to 9? Well, 5 plus 7 adds up to 12. That is greater than 9. And so it can form a triangle. And then the next step we're going to do is we're going to compare c squared with a squared and b squared. So again, we want to start with the c squared. We're going to compare that to a squared plus b squared and see whether it's less than, equal, or greater than. So c is always my largest number. So up here, 9 is going to be my c. So how does 9 squared compare to 5 squared plus 7 squared? 9 squared is 81, and 5 squared is 25, and 7 squared is 49. If I add 25 and 49, I get 74. So 74 is less. So 81 is greater than 74. If c is greater, that means essentially, if we think of a door hinge, the door is open wider, so it is obtuse. Look at the next one. This was one that we did on the previous slide, and we know it isn't a right triangle because that's not how it came out, but if I look at 24 squared and compare it to 21 squared plus 16 squared, you'll recall that 24 squared was 576, and when I did 21 squared plus 16 squared, I got 697. Well, 576 is quite a bit less than 697, therefore I know that it's an acute triangle. So here are a couple of problems for you to try on your own. Decide whether the numbers can represent the side lengths of a triangle, and if they can, classify the triangle as right, acute, or obtuse. I want you to try to do these on your own. Pause the video now. Okay, so for example C, first of all, we know the square root of 8 is almost 3, since the square root of 9 is 3. So a number that's almost 3 plus 4 is going to be greater than 6, so I know that it is a triangle. And then I compared c squared to a squared plus b squared. So c squared would have been 6 squared, which is 36. And then when you square the square root of 8, that's 8, plus 16 comes out to 24. 36 is greater than 24. Therefore, this is an obtuse triangle. And for problem D, again, it is a triangle because 20 plus 21 is more than 28. When I compared c squared to a squared plus b squared, I ended up with 784 for c squared, and then a squared plus b squared came out to 881. So since 784 is less than 881, I know that it is an acute triangle. And that concludes this video. Thank you.